You're going to use the handout on lesson 1, which is ways of knowing. As I go through this presentation, you'll fill in some blanks and you'll take some notes about what science is. So by the end of this lesson, you'll have a definition of science. You'll be able to list, define, and provide examples of the characteristics of science. You'll know the difference between observation and inference, though we'll have a lesson with a bit more detail on that later on. And you'll understand what it means to what indigenous ways of knowing are, and why they're so important for science in today's day and age. So what is science? What I need you to understand is that science is not just definitions in your science textbook. Science is actually a combination of different things. So it's not just the knowledge that's in your textbook, but it's also the processes that were used to discover or generate this knowledge. So if we were to put all that together, we'd say that science is the knowledge gained from using observations and experiments to describe and explain the world or the universe around us. So really it is a way of knowing things. It's a body of knowledge. So yes, it is a collection of definitions and facts, but it's the methods or processes that we use to figure out that knowledge. What are the experiments that we use to figure out that knowledge? So when you look at a scientific textbook, you're not really seeing the history, the processes that were done to figure out, what is a cell? Why is the electron negative? How do we know it's negative? You do science rather than just memorize science, and that's important to understand. So what is the whole purpose of science? Really, it's to learn about the universe. So when we have a question about the universe, we ask that question and we try to do experiments to learn and discover the answers to that question. And typically we make observations, and the more that we observe, the more questions that we have, and the more science that we do to find answers to those questions. So it's a never-ending cycle. We observe, we ask questions, we observe some more, we do experiments, we observe some more, we gather results, we have more questions, and we just keep questioning. And so what's important to understand is that science is good. It can be good for humanity. For example, it can help us find solutions to climate change. But we also need to understand that because science is done by humans, and humans are not perfect, science is also not perfect. Science can harm humanity. It's been used to perpetuate racism. And if you think about it, although it's finding solutions to climate change, science has led to climate change, right? We started burning fossil fuels using principles of science, and that is now leading to climate change. So although science can do a lot of good, it can also do a lot of harm if not done properly, and if not analyzed ethically to see that we're doing good rather than doing harm. So keep that in mind. Science is not immune to biases because it's done by humans. So what are the main characteristics of science? There's 4 main characteristics that we'll discuss. The first one is that science is tentative. Tentative just means that new information can change the way we think about things. So at one point in time, people would tell you that the earth was flat. But with observations and evidence, now we change our understanding and we know that the earth is round. At one point in time, a long time ago, smoking cigarettes was not really considered an unhealthy thing to do. But with more evidence and information, now we know that smoking cigarettes is unhealthy and shouldn't be done. So the idea is that science acknowledges that it will change over time based on new information. As we develop new tools and ways to observe things, we can gather more specific information that can lead us to better understand our universe. And so that's why we say science is tentative. What you learn today may be different than what you learn in a few years from now because we gathered new evidence and information. And that's important in science. The other characteristic of science is that it relies on evidence, on clues. It's not just made up. It relies on empirical evidence, on data. So when we say something in science, what's important to understand is that it's based off of true results and data that we've collected. So data can be collected in a few ways. You can use observations, which are your 5 senses, to describe how things actually appear. So what did you see, hear, taste, smell, or touch? You can also use inferences, which is not something you directly see, but something that you conclude based on observations. So for example, let's say that I touched a door. Using my sense of touch, I noticed the door was hot. That's my observation. So it was hotter than it should be. And I also noticed that I saw some smoke. So using my sense of sight, I saw smoke, and I smelled something burning. So using my sense of smell, I smelled something burning. So those are all observations I made. An inference is because I touched the door and I saw smoke and I could smell something burning, there might be a fire on the other side. So using inferences and observations, science can better explain the world. So it's not made up, it's using true data points based on your observations and inferences. So let's do an example here. What you're going to do is you're going to observe this image for 30 seconds in the slide deck. You're simply going to watch it for 30 seconds. And then I'll actually start a timer here. So we'll start a timer for 30 seconds. Observe as much as you can. Don't write anything down. Just look at it and make observations. All right, that was 30 seconds. Now, we're going to try to answer some questions. Don't go back to the video, to the picture. Just try to answer questions based on memory. So what time was it? 10:30 p.m. What was the date? December 24th. How many people were in the picture? 7. What did the person have a tattoo of on their arm? A snake. What was the second person in line holding in their left hand? A milk carton. Describe the person at the front of the line. Were they tall or short? Tall compared to others. Were they wearing glasses or not? Glasses. What were they doing with their hands? Left hand giving object to person. Right hand in pocket. So those were all observations that were made. Notice for question 6C, what were they doing with their hands? If you said paying, that would have been more of an inference because you don't know if they were paying the person. Making the observation is simply describing what you see. So their left hand was giving something to a person and the right hand was in the pocket. We don't know what that something was. Maybe it was a ticket, or maybe even giving was an inference. Maybe they were receiving something from the person based on the picture. Who knows? Depends on the situation. But maybe they were receiving a ticket or giving a ticket to the person. So there were a bunch of different scenarios that could happen that you could infer, but the observation is they were giving or receiving an object to or from the person and their right hand was in their pocket. So those are simply observations, and then from those observations you can make inferences. So maybe you could look at the date December 24th, and you could look at the Santa Claus in the previous picture here, and you can make assumptions of perhaps the season in this area. So those are all different things you could look at observation-wise, and you can make inferences from those observations. The last two characteristics are trial and error and collaboration. What's important to understand about science is that it's not perfect the first time you do an experiment. Science requires many attempts to understand the world around us. If we're trying to find a cure for a disease or create a drug that helps to cure a disease, the first trial is never perfect. You have to do thousands of trials until you find something that allows you to treat that disease more effectively. So trial and error is actually a very important part of science. We make mistakes, we try again, we make our experiments better, and we do that over and over and over and over again. So by understanding that science is not perfect, you start to treat science like a puzzle, rather than there's a wrong answer or right answer all the time, and for that reason, science always continues until you can fit the puzzle pieces together. And also collaboration. Scientists actually share information. So once they discover things, they share information in journals, online, and that allows them to gather information to better their experiments, to discover more things, and that's a super important and really great part of the scientific community. They work together to solve common problems of humanity. So those are the four main characteristics of science, and we're going to take a look at now indigenous ways of knowing. So oftentimes in school, what you're taught is more of what's called a Eurocentric or Western way of knowing, Western science. And you'll see here there's quite a few differences between Western science and indigenous ways of knowing. Indigenous knowledge systems are super important because they've actually been around for countless generations. So these are not new knowledge systems. They're based on individual experiences, but also collective experiences to explain the world around them. They're verified over many generations by elders. They're actually conveyed and communicated in many ways, through oral traditions, through experiential learning, by other methods of record keeping. And they're very holistic. Indigenous ways of knowing, indigenous worldviews, look at the whole context, the whole person. Everything is connected. Whereas oftentimes, Western science removes parts of the whole, and it's not a complete understanding of what we're trying to study. So this is a great article here. If you actually open the PowerPoint up and click on this link, it's called Western Science is Finally Catching Up to Indigenous Knowledge. And so sometimes you'll see an article published where it says Western scientists discover a certain concept or a certain phenomenon. But then when you go interview indigenous elders, they'll tell you, well, you know what, we've actually known this for a long time, or our peoples have been doing this for a long time on our land. We already knew this, so this is not something you discovered. If you just spoke to us and included our voices in the narrative, you would have understood this to begin with and had a more complete understanding. So the main point of this slide here especially is to truly understand that we need some change in our science. A lot of voices and experiences have been and continue to be undervalued and erased and excluded by colonial Western science. And by looking at things from multiple perspectives and having diversity in the scientific community, we're in a better position to understand the world through everyone's perspective. The world doesn't belong to just one person, one individual. The world belongs to everyone, and so science should belong to everyone. And that's something to continue to think about as you pursue your career in science or your studies in science as you move forward. Understand that science is for you. Science needs your perspective, and the only way to really change this current bias that we have is by first of all starting to be aware of it. So in this lesson, there was also a tangram activity. You may or may not have done it, but the point was you would take these pieces, put them together to make a shape that makes sense, and you would have had a square. Afterwards, your teacher would have given you the X piece and said, incorporate the X piece into that square. And you would have seen that this was a lot harder to do, but by manipulating the pieces around over and over again, you would have eventually found a solution to incorporate the X piece to make a square again. But not everyone could do this X piece on their own, so then some of you maybe tried to collaborate in order to share ideas to see how you could fit the X piece in. And the idea is that this tangram activity connected to the different characteristics of science that we saw. So how did the tangram activity connect to the different pieces of science that we saw, or characteristics of science? Well, first of all, the pieces themselves acted like evidence or data that scientists would collect to learn about the world. So it relies on evidence. The students yourselves basically tried to put the pieces together, making observations, looking at how the edges and borders would fit together. You probably did some trial and error. Maybe the first time you put two pieces together, you thought it would work, but it didn't, so you took them apart and put another two pieces together, and that did work. So trial and error was an important ingredient in this activity that allowed you to solve the problem. Now, the first time you built the square and the teacher came along and gave you the X piece, that represented science being tentative. The X piece was a new piece of information that forced you to change your way of understanding the world a bit more. And you had to now incorporate this new piece into your understanding. So it changed the way you viewed it. Collaboration. So if you couldn't solve the X piece on your own, maybe you got some clues or hints or ideas from people. And also something else that we didn't quite mention is that some of you just got lucky. You found the answer by putting two pieces together without even thinking about it, and it just worked out. Sometimes that happens in science too. Sometimes you discover something without quite realizing or without having a plan in mind, and that leads to an answer just out of nowhere. So science doesn't always have to be perfect and planned. Sometimes it could just be we make an observation, and that led to an important discovery. So one example of that is sweetener. So artificial sweetener was actually discovered by accident, where scientists had a bunch of chemicals in the lab. The scientists licked their finger and noticed it tasted sweet. And you should never do that. You should never lick your finger after you're in the lab. It basically discovered artificial sweetener that you would put in your coffee or tea. And so that was an unplanned experiment. It was an unplanned discovery. And sometimes luck just happens well. But the whole point is that this tangram activity was used to relate to all the different characteristics of science. So part of your homework is to complete the learning goals in this lesson in your handout. You can start thinking about how you'd like to summarize your this lesson. Remember that in your lab notebook for each unit, you're allowed a 2-page summary. That may change depending on the year, so make sure you double check with your teacher just in case that has changed. And you can also watch the video within the PowerPoint here to start helping you think about the next lesson that's coming up.